Okay, so today we're going to piece together a pretty fascinating technological puzzle. It all comes from a company called Radical Deepscale. We're about to go on a journey that starts with a really niche mathematical tool and it ends with an AI that literally invents futuristic materials. Let's just dive right in.
And it all kicks off with this quote. A mathematician and 3D artist, Justin Venable, is describing this tool he built, and then he just casually drops this line that it's just a side product of their main project, Arc Lake. That's the kind of thing that makes you lean in, right? I mean, if the tool we're about to see is just the warm-up act, what in the world is the main event?
All right, so let's start our investigation right there, with that side project. It's the most concrete piece of this whole puzzle. The tool is called ArcEdge, and it's built to measure something very, very specific.
Think about it like this. Measuring a perfect circle? Easy. A straight line? No problem. Our math is great with symmetry. But the real world, it's messy. It's chaotic. How do you actually measure the curve of a splash of water, or the turbulence coming off an airplane wing? These things are called finite arcs, and for a long time, they've been a total mathematical nightmare. Well, ArcEdge was built to do just that, to tame that chaos.
And here it is. This is the tool itself. Now, it might look like some kind of complex 3D visualizer, but at its very core, its creator just calls it a measurement tool. So imagine a super specialized ruler, but instead of measuring straight lines, it's designed for the wild, chaotic curves you see in nature. It puts a grid, a system of measurement on things that were basically considered unmeasurable before.
So, okay, why go to all this trouble? A hyper-specific measuring tool for weird curves? It sounds kind of academic, right? But this is where the puzzle box really starts to open up. See, this ruler wasn't just built for us to measure things. It was built to teach something else how to see.
Because that unique mathematical idea behind ArcEdge, it's not just a principle for a tool. It's the fundamental sensory input for an incredibly powerful artificial intelligence. And its name is Ariel.
And this is Ariel. Or, well, this is its interface anyway. Just look at the name of this screen, the Ash Buoyancy Execution Log. You can tell right away, this is not your average chatbot. The screen is just packed with these complex data streams and a very specific, almost biological-sounding vocabulary. This thing is seriously sophisticated. Now, you don't need to memorize all this jargon, but just look at the kinds of words being used here. Shell, foundation, reflex. That's not the language you usually see with a data crunching algorithm. It sounds more like, well, like biology. It suggests an AI that's built with layers and core structures and maybe even something like instincts, these reflexes. It tells you that Ariel is designed to perceive the world in a totally different way.
And this is where it all clicks into place. The ArcEdge math, that ruler for chaos we started with, it's not just for people to use. It's the foundational sense for the Ariel AI. It's how Ariel sees and measures and ultimately understands the complex, chaotic systems of the physical world. It gives the AI a feel, an intuition, for physics.
So, you have a special ruler that gives a powerful AI a sense of the physical world. What do you do with that? Well, you put it to work on one of the hardest problems there is in physical engineering, inventing entirely new materials from scratch.
And here is one of Ariel's creations. It's a hypersonic alloy called T11-Z. Now look at this recipe. It's not just mix these things together. The AI is designing an entire process. It's using elements like zinc and calcium for the specific purpose of engineering the properties of nickel, which then acts as the foundation for the tungsten in the final product. It's like an AI chemist. And the results it's aiming for are, well, they're extreme. This isn't just any old metal. It's designed for hypersonic applications. That means it needs incredible resistance to heat, to corrosion, to physical stress. These are the kinds of material properties that push entire industries, like aerospace engineering, forward.
Just stop and think about what this means for a second. The old way of doing this, creating a new alloy, it could take years, maybe even decades of slow physical trial and error in a lab. But this new method is a whole different ballgame. It is fast, it is simulated, and it's all driven by an AI that can run through thousands of designs virtually before a single atom is ever melted in the real world.
So, now we have all the pieces on the table. We have a new kind of math, we have a unique AI that uses that math to see, and we have a tangible, futuristic material that it created. It's time to reveal the main project, the thing that creator mentioned way back at the beginning. It's time to talk about Arc Lake. And this is ArcLake. It's a virtual chemistry lab. This is the central hub, the command center, where all these other pieces come together. You can see the tools for messing with molecular structures, for running physics simulations, and right there, a direct link to the arc edge factor, tying it all back to that original ruler for chaos.
Really, the best way to think about it is like a virtual sandbox for chemistry. It's a simulated universe where the aerial AI can play with the building blocks of matter, guided by those arc edge principles, to design and test new materials at a speed that was just unimaginable before now.
So here it is, the entire workflow from start to finish. It all begins with a new mathematical principle, a new way to see the world. That principle gives the AI brain a kind of physical intuition. And with that intuition, it can produce a real, tangible output, like a futuristic alloy. It's a complete and kind of beautiful system for invention.
So what we've just pieced together here is more than just a collection of cool software. It really feels like it represents a fundamental change in how we might invent and engineer things in the physical world.
This whole ecosystem, from the math to the AI to the virtual lab, it all represents a single, unified vision. It's a complete platform designed for discovery, moving way beyond just analyzing data to actively designing the physical world around us.
And that right there is really the key takeaway from all of this. What we're looking at isn't just a smarter way to make an alloy. It's a glimpse into a brand new paradigm, where AI doesn't just help us organize our information, it becomes a creative partner in literally building the physical future.
Which, of course, leaves us with one last fascinating question. We've just seen an AI that can basically act like an expert chemist, inventing the very building blocks of our world. If it can design new materials for us today, what is it going to build for us tomorrow?